Hello and welcome to this GLOBEClaritas video on what's new in version 6.10, which was released early July 2019. This release was a relatively short duration release, as we were trying to resync back on our preferred release schedule of mid-year and end-year. So what we've done is a number of sort of relatively high value, ease of use and improvements around interacting with external files, etc. So I'll show you the first thing, which is using the Velos application. So there's a number of new features in the Velos. One is the ability to read in and reformat external velocity files. So whether they've been delivered to you in SOV2, UCOA or Promax velocity format. You can now read those in Claritas' Velos application, review them, and then write them out to an NMO velocity field. So you can now see that on the initial parameter form for Velos, there's two buttons. There's the NMO file, so if you want to read in a standard Claritas velocity format, that's fine. You click on the NMO file and select from the NMOs. Otherwise, you can go to the Velos folder or where you've got your velocities kept. So in this case, I'm going to go to C drive, users, Andy J, and there's a Velos_SPS, and I'm going to select the 3D Velos.asc. And then from the file format, I can select either one of our pre-configured SOV2 Disco versions, Western 3D Shell, Promax, UCOA, etc. Or if it's a non-generic ASCII file, I can select the custom option, and this one happens to be one that doesn't conform to our existing preset types. Click OK and it will come up with another parameter form with a bunch of parameters where I can define how to ignore lines, or what lines have the time velocity information on them, comment lines that I want to ignore, etc. And then I can basically define the column ranges for the time velocity pairs. Inline column sits in what column range, and the crossline column range, or possibly CDP or shot point column range. So if I then, once I've got that configured, and this happens to be the correct parameter, so I've got my time velocity columns are between columns 21 to 40, inline columns 1 to 10, and 11 to 20 are where the crossline sits, and it's a 3D velocity field as it says in the name of the file. Click on that, and it goes through and reads in and displays them on in the Velos application. So I can then QC and make sure that the velocities look sensible. Maybe deal with any problems, any weird interval velocities or inversions or anything like that. And then if I'm happy with it, I can click on the repick and I can select on existing points, and I can give it a new output file name. So test 3D.nmo, and write that out, and that will write that out into the velocity subdirectory of the project I'm working on. So as you see, we've now got a lot of improved functionality around reading in external velocity formats, certainly over and above where we were, where we basically had a bunch of awk scripts which were worked but didn't give you the inbuilt QC to check that, make sure everything's fine. You'll also see that we have also the option to now export velocity files from Velos as well. So we can decide where we want to write them to and the format that we want to output them in. So at the moment we support as outputs Western 3D, Shell, Promax 2D, 3D, UCOA and Statoil formats. If you've got another format you prefer, then let us know and we can provide us with a format description, and we can add that to our output versions. So I'll exit out of Velos, and then the other improvement we made to Velos is Velos always had the ability to read in segue velocity fields, but unfortunately wasn't very good at reading in segue velocity fields that were for 3D data sets, because it wasn't interpreting the inline crossline location properly. We've now sort of updated that. So if I go to Claritas Sequin, Home, Andy J, make this off, and I have an example 3D velocity file in there. Click OK on that. It's quite a big file, so it'll take a little while to load up. You see it's beginning to load, and then we'll get basically the inline panels down the bottom. So it's still loading away at the moment, and then we can basically click along the line and move to a different velocity point along the line. So you can see it now reads 3D velocity fields correctly and interprets them correctly. So we now have, it produces the inline cross lines. So you can QC the velocity fields effectively, and if you want to, you could do some editing, smoothing, that sort of thing to the 3D velocity files. So I'll exit out of there. I'll talk about improvement to the NMO trace module. So I'll just open up a dummy job file, app NMO trace. So I'm sure, as you're aware, that previously the NMO trace module has always been able to read data in and either replace the existing seismic data with the velocity trace or create a pseudo trace header where the velocities were saved so that you could display an overlay of the velocities and the seismic. What we've added in here now is the ability to input both VRMS and VINT, so we can then do the overlay and display of either RMS velocity fields, or if we have an interval velocity field, we can read that interval velocity field in and display that as an overlay on the data set as well. And then you'll also notice there's an option here as well that once you've created that velocity trace data set, if you want, you can now write that out as a Segway revision 1 data set directly from NMO trace rather than having to use write Segway later in the job flow. It makes life a little easier. In addition to the improvements to ISOVELs, we've also had some further work done on the RefStat applications, both 2D and 3D. I'll show this with the 2D RefStat. So if I click on the button for 2D RefStat and launch it, I've already got HDF5 dataset files selected for both PIC and JOM files, and click OK. The first thing to notice is that rather than opening up an external window and logging everything in there, we now have a full proper logging window for reporting what's been occurring in the RefStat application. So basically anything you do in RefStat in terms of changing or when you're running the inversion process, then everything will report it into this logging window, and when you save and exit, this logging window will save out to a log file style file that you can basically view later and check as you need to. So in terms of other changes to the RefStat application, we've also added in some capability to deal with low quality or bad first break picks, and we have two methods of dealing with this now. I'll show you the automated method first. So if I go on, click on the calculate button, I'll give it a name of model 2, give it 2 iterations because I don't want to spend too much time for it running this. And now there's a new parameter called high residual rejection factor, and this is basically defining the amount you're allowing the residual to change between the picked and the modeled first break. And it's expressed in standard deviations from the mean of that residual. So typically we would recommend 4 standard deviations as being a suitable amount of variance from the mean. So anything above that we definitely want to get rid of. So if we click OK, basically we'll see, go through, run that, and you'll see that basically we start off with quite a high RMS, but rapidly it drops down once for the second iteration. That's because we're sort of excluding those. If I bring up the log file, So basically, in the log file now, you can see what the sort of RMS residual is. And then at the second iteration, we can basically see that it's now, because of that parameter we've set, it's going to ignore 802 picks with a residual greater than 5 times the RMS. So that's excluding those. So that's an automated way of doing it. The second option for removing poor picks is to click on the TX display, and brings up the TX display of the first break picks. We then show all picks, and in there at the moment we can see the ones that have been removed because they're the sort of little light green dots. And then basically what we can do is select a polygon around what we consider to be the suitable cloud of optimal or highest quality first break picks that we've got in those that we've picked, and then basically pick a polygon around. Then we'll basically tell us how many picks we're excluding. So in this case it's around about 1.3%. Click OK. And then again, if we then go to calculate, we've sort of exclude those from the inversion. We go to calculate, make that model 3, click OK. And again, you can see that again, we're sort of rapidly coming down in terms of the RMS in that logging window. So those are two methods of excluding poor picks. So rather than having to sort of go through and look at every single pick and try and find the bad ones and pick better picks at those locations, we can now just bulk reject or use an automated approach to throw away the ones we don't want. Once you've picked a polygon, we can save that polygon out as a .pol file in the mutes directory, or if we've already got a picked polygon, if we've gone back into refraction statics and we want to do some more work on our refractions, we can load that polygon back in here so that we don't have to pick it every time we want to remove them. So that's our sort of updates for RefStat this time around, which adds some significant value to things. And then I'm going to move to a different project and just quickly go over the latest sort of thing which we've added into the wavelets application. I'll click on that. I'm not going to load a wavelet session file. So now under the create option, we have the option to create a vibrosize sweep. We can only at the moment deal with linear vibrosize sweeps, and we'll see how we go with that. But basically, we can create a vibrosize sweep. We can define the sample rate that we're expected for the field acquisition, the trace length we want to create, the frequency range we want to sweep across, and the taper length that we want to apply. Hopefully all that information you'll have received as part of the information about the survey. If you're reprocessing a data set that's lost the vibrosize sweep, I'll stretch that out so you can see it, and that creates our vibrosize sweep. And then we can save that out as a text or a segway file. In this case, we'd save it as a segway file. Test bib sweep video. And then that writes it out into the data directory in this case. And then basically we can then go to the job flow, display news first, and then hopefully we should be able to find, there we go, synthetic vibrosize correlation. I'm going to use one I created earlier. So that's one I created earlier, which is along the sweep length. And if I run that, it's applying our created vibrosize sweep to our uncorrelated raw data that we've received. And we get a nice looking shot record at the end that we can then process through as we normally would. So again, if you've got a data set where you no longer have the vibra-size correlation, you can now create one as long as it was acquired with the linear sweep method, and you should be good to go. What I will also show you is, again, if I rerun that job, because it takes a reasonable amount of time to run, now you can see that this, in the logging window of the XSGE window, when you're running it, that the scroll bar down the side is now active. So you can basically scroll up and down and have a look at what's going on. And basically, if you leave it there, then it will stay there, it won't move, and then it won't start you won't see what's new in there until you drag it down to the bottom of the scroll window. So that means that the log files, when you're actually running a job flow, are a lot more useful than they used to be. I'd now like to talk about a couple of new modules that are available in the latest v6.10 release for users to test and see how they work on the data. So first one I'll talk about is the Dino TF module. So if I open up a job flow and sort of explain a little bit about the module. So it's a new noise attenuation algorithm, basically using tensor factorization, which is a AI-based denoising solution. So basically, it's an image sweep module. So you provide an input data set, an output data set, and in this case, we define the starting peg location and end peg location we want to process. We define a tolerance, i.e. how closely the calculated factors match the input data. So the smaller the value, the more closely the calculated factors will match the input data, and if you go too far in that tolerance value to make it really small, it will then also start trying to match the noise, i.e. the information you're trying to extract and remove from the shot gather. So you need to be careful about how you make or what values you use in the tolerance. Because alternatively, in the other domain, if you make that number too large, then it will basically match less of the input data to the calculated tensor factors and therefore remove more signal. So it's a sort of a compromise between matching really closely to the input data and allowing some the application to get to work and try and attenuate noise effectively. This tolerance parameter also has an effect on the run times of the data. So again, smaller the number, more factors calculated, the longer the application takes to run. Bigger the number, fewer the factors, if you like, that are calculated, faster it runs. So again, it's a trade-off between quality and speed as well, a little bit in terms of that parameter. So the symmetric parameter defines whether you've got a receiver peg at the same location as a shot peg. And generally we try and have that, or most data sets will conform to that, where there's a shot and receiver pegs reasonably coincident, such that we can treat the data as symmetric, i.e. common shot pegs will look similar to common receiver pegs, etc. So we'll say yes generally to that. We can write out, so we can run an initial job with our start peg, end peg parameters and symmetric values defined, and write out the factors that we pre-compute. They'll be close enough such that when we play around with the tolerance, we can read those factors back in and speed the run times up a little bit. So that's what we generally do, is if you run your first pass with your min-max peg values defined and defining whether it's symmetric or non-symmetric, save your factors out and then read those factors back in for your further tests. And then it's standard MPI command structure as with most image suite modules. We are still working on Dino TF, so we've done some initial work in release 7.0 of Claritas for improving run times of this, and Mark's currently working on improving the quality of the results, so getting it more stable in terms of better at moving noise, but also better at preserving the signal. So hopefully as we step through, and certainly with the new beta release, you certainly should see a denoise TF that's faster to run, but hopefully also some improvement in the quality. But take a look and see whether you has any benefit to you on your data. And then the other module that's new in this release, which I'll just add into this job flow, is the FK Power module. So this is generally a post-stack application. So basically what it does is takes your stack data set, transforms it into the FK domain, increases, raises that FK spectra by a user-defined power, and then transforms back into the XT domain. The expectation is with that with that sort of boost in the FK spectra, you'll boost coherent signal, and random noise will be less obvious in the dataset once it's been in and out of the FK domain and had that power value applied. So it's quite a nice little simple post-stack coherency improvement module. So again, give it a try, see what you think, see what it's like. Other than that, that's pretty much all that's new in GLOBEClaritas 6.10. We've started obviously the 7.0 release development cycle, but hopefully take a look at what's new in 6.10, and obviously we'd appreciate your feedback on Claritas and recommendations or suggestions for where we can further improve the software. So if you want to get in contact with us, send us an email to claritas.support@gns.cri.nz. Thank you and goodbye.